we have already done essential amino acids. So we were on amino acid classification. So we classified amino acid based on nutritional requirement. So nutritional requirement, we classified first. Actually, we have seen a broad classification of amino acid. So we classified amino acid into standard and non-standard. So standard amino acid are the amino acid which are present in protein. Non-standard amino acid are amino acid which are not present in protein, but they are biologically important. So I have given you example of non-standard amino acids, very, very important examples, and non-standard. And then standard amino acids are, these amino acids are modified standard. Modified, that will be modified when it is incorporated into the protein, then it will be modified, not before. So modified amino acids, I gave you hydroxy example, hydroxyproline, carboxy, gamma carboxyglutamate, then normal standard. So we are classifying this normal standard amino acids. And also remember, after this standard amino acids, we have 20 amino acids. And then there is 21st amino acid, that is selenocysteine. So these are the amino acids classification. Now we are classifying this normal amino acid before in terms of nutritional requirements. So we will see which amino acids are nutritionally essential, which are nutritionally non-essential. Now we have already done this nutritionally essential amino acids. So these 10 nutritionally essential amino acids are very important. So if you understand this 10 nutritionally essential amino acid, then the rest 10 will be nutritionally non-essential amino acid. So you can see here. So these two, cysteine is actually nutritionally non-essential amino acid. It can be synthesized from methionine. And this tyrosine is non-essential amino acid. These are synthesized from phenylalanine. These are also, both are aromatic amino acids. Both have this ring, this benzene ring. So benzene ring is an aromatic ring. So both have benzene ring, and this hydroxylation of phenylalanine will produce tyrosine. So there will be CH2, CH, and then CO. And here you will find NH2. This is tyrosine. Now cysteine is sulfur containing amino acid, and this is made from methionine. Wherever in protein you see disulfide bond, it is because of cysteine. Remember this. Wherever you see the disulfide bond, it is because of cysteine. So one question is here. Here is one question. Which of the following amino acids contribute for disulfide bond in protein? So this is the answer. Cysteine will contribute for disulfide bond always. And then after cysteine, so cysteine is very important in that way. Now phenylalanine, tyrosine is so we will talk about the structure of all amino acids. So we have already done cysteine. Remember, don't forget this cysteine. And next you can see the few amino acids. You can see these are glutamate. That means these are acidic amino acid. Whenever you see such terminal glutamic acid, so this is a acidic amino acid. Whenever you see aspartate, so aspartic acid, this is a acidic. Both are acidic amino acid. Acidic. So we will see the structure also. For the time I am telling you, these are acidic amino acid. So this amino acid can be easily synthesized from carbohydrate. These, so two are synthesized from one. This is from methionine. This from phenylalanine. These are synthesized from this. So actually, if you see, if you talk about cysteine, just methionine, cysteine gets sulfur group only sulfur group from methionine. It gets carbon from serine. So serine and methionine both will make this cysteine. And these are all formed from carbohydrate. Glutamate, you can also see glutamate can, the counterpart of glutamate as alpha ketoglutarate, which is a part of Krebs cycle. So from alpha ketoglutarate, glutamate can be synthesized. It's easy to understand. Now oxaloacetate, it is the counterpart of this, like keto acid of, this is amino acid, keto acid of aspartate is oxaloacetate. And you know, from oxaloacetate, this aspartate can be easily synthesized. So you can see the synthesis also. From oxaloacetate, aspartate can be synthesized. From alpha ketoglutarate, glutamate can be synthesized. Now, after this, you can see. So I will upload all this on YouTube. So go and watch that. If you don't understand anything, so you can watch that video from this. So go back and revise those content. See this. So this glutamine, this is glutamine. This is amide of this glutamate. Amide of glutamate. And you know this glutamine synthesized from alpha ketoglutarate, from carbohydrate. I am telling you synthesis also. So see, remember that. So I am actually talking in a very like broad view, so that you will understand things a very better way. If you understand right now, so you will have a very good foundation. Aspartate is from oxaloacetate of Krebs cycle. So you already know Krebs cycle. And that is why I am telling about this. Now from glutamate, glutamine can be synthesized by addition of ammonia. Now from aspartate, asparagine can be synthesized. So this from oxaloacetate aspartate to asparagine by addition of NH2. This because of these are amide of aspartate. So this way, this structurally these two amino acids are same. These two amino acids are same, and these both are acidic amino acids. Alanine, glycine, these are very simple amino acids. Alanine and glycine are very simple amino acids. Simplest amino. First, this is simplest. First simplest. First, this is the first simplest amino acid. This is second simplest amino acid. So these two are very simplest amino acid, and this alanine can be synthesized from pyruvate. You know pyruvate. Pyruvate is synthesized from glucose. So this way you can understand from this pyruvate only oxaloacetate is synthesized. I have already taught you from pyruvate carboxylase. So this is the link how you will find. So from oxaloacetate aspartate, from pyruvate or this alanine. This way everything is synthesized from carbohydrate. All these non-essential amino acids are synthesized from carbohydrate. That is what I want to say. And then after we talk about this, we will talk about the branch chain. So we will talk more about the structure of side chain. So we will here talk about the structure of side chain. Let me first talk one thing. So let me first draw again the structure of amino acid here. So structure of amino acid, as you know, this is amino group here. I will write amino group here and this acid group here. So this becomes amino acid. So what is left is 2 bonds. So 2 bonds can be filled by adding one hydrogen here and this R group here. So this, from this picture you can see this is a like hand. So I'm animating this. So that you can remember. So this is you can feel like a hand, this hydrogen like body, and this is the face of this whole thing. So you can take like you can view also like wings and something like that. So anyway, so I have animated. So this is the face of amino acid. Amino acid are different from this R group only. So when you understand the R group, you will understand different amino acid. Now let me first talk about very simple amino acid. So if you understand this very simple amino acids, you will understand. So in place of R group, let me draw the structure again for this for one amino acid. So this is the amino group, and this is acid group. So this is H. So what would be the simplest structure that I can put here? Just tell me. Anyone? In place of this R group, what is the simplest thing that I can put here?
Hydrogen.
Yes. So I have put here hydrogen. So what is this compound?
Lysine.
This is glycine. This is the simplest amino acid. Now let's see. So add NH2. This is amino. This is acid. So H group. What should I put that will become a next simple amino acid?
CH3.
CH3. Now I'll tell you the CH3. If I put CH3 and amino group, isn't it very similar to a structure of pyruvate? Isn't it very similar to structure of pyruvate? This is amino. This is acid. This is amino. This is amino acid, and this is hydrogen. When I put CH3 group, this becomes what? Alanine. And simplest, when you put hydrogen here, this becomes glycine. So isn't it very similar to glycine? This pyruvate.
Yeah, yes, sir. Pyruvate also 3 carbons.
Yeah, that's good. Pyruvate has 3 carbons, and it is a keto acid. First is acid, second is keto group. In place of keto, you will find amino here. So you can write this pyruvate like this. So you can write pyruvate like this. This is acid, and pyruvate is a keto acid. And generally, we used to write the pyruvate like this. At the top, I used to write acid, then keto. Then aren't this similar? Just in place of this amino group, there is keto group. So this is amino acid, alanine. So you know glycine, you know alanine, and then so you can see the simplest amino acid you can see here, alanine and glycine. So remember these 2 amino acids. This V structure. So simple. This V structure is very similar to, you can say this is a, you can write this with, this is a, you can write amino group here. And then this is, so V, you can convert this V into, this is alanine. So alanine, you write alanine A and like this. So this is alanine. This is how you can remember the structure also. This is alanine. And glycine, so you just see glycine. This is glycine. So remember that way. Glycine is very simple, simplest amino acid. Here is one hydrogen, here is one hydrogen. So that is why glycine, and this is alanine. Now we will, if you understand, I'll correlate in a funny way when I teach you codon. When I teach you codon, I'll relate this structure in a very funny way to the codon. Now after this, after I talked about glycine and alanine, let's talk about branch chain amino acid. Branch chain amino acid. So branch chain amino acid. So this is amino group, and this is acid group. Now you add acid. This is the general structure of all amino acid. In place of R, if you write CH3, with this CH3, if you add one CH3, CH only. Here, if you write this CH3, what does it become? This, isn't it a branch chain amino acid? Now, yes. So here you can see this type of structure. This type of, can't you see this type of structure here? Can't you see? Can I write this like this? Can I write like this? So if you see this is like V. So write it like valine. So this is valine. So valine is a branch chain amino acid. So with this amino group, this side chain is valine, V. Now after valine, so just extend this structure. Now in place of V, you add this one more carbon, and then you add this V. This is what is leucine. Okay, so leucine has one more carbon. Leucine. There is third amino acid called isoleucine. This is amino and this is acid and then hydrogen. Now you can write like this. So sorry for writing right now, it is not required. So CH, then now H3, put this H here. Change a little bit the structure of leucine. It becomes iso. Iso means similar to leucine. So these are the branch chain amino acid, and these branch chain amino acid are essential amino acid. Because branch chain our body cannot make, that is why this branch chain are essential amino acid. So number of carbon, if you can see valine. So V valine is, you can see V is like 5 Roman letter, and it has got 5 number 1, 2, 3, 4, 5. So 5 number of carbon is there. Now leucine and isoleucine you can easily understand because they are just 1 carbon more than valine. So that is why they are 6 carbon. This is also 6 carbon. So did you get this? Tell me if there is any problem. Just let me know.
No problems.
Okay. So you can see I have explained you this glycine, alanine, and I have explained you valine, leucine, isoleucine. Now let's talk about this serine and threonine. So it will become, this both are what type of amino acid? This both are hydroxyl group containing. So you have to memorize this all. If you don't memorize, that will not be good. So if you want to have a concept of amino acid, you will have to memorize which amino acid has hydroxyl group, which amino acid has sulfur group. So these are the part of, we will ask question from this part. We will ask question from this part. So you already know, I will ask question from this also. So it is synthesized from which pyruvate, I'll tell you. So alanine is keto acid of which amino acid? Alanine is keto acid of, is synthesized from which keto acid? So it is from pyruvate. Aspartate is synthesized from which keto acid? It is from aspartate. Glutamate is synthesized from which keto acid? It is alpha ketoglutarate. So you will have to understand this all things.
That's what you just said.
Yes.
Aspartate is originated from where?
So can you see here on the screen? So what do you find here? Just see here where I am pointing. What is this?
Aspartate.
Is synthesized from what? Which keto acid? This is keto acid. So these are the part of question. I'll tell you. So wherever I see question, I'll ask you question from that. Now, hydroxyl group amino acids are serine and threonine. So these are all simple amino acid are this. Branch chain amino acid are this. So hydroxyl group containing amino acid are serine and threonine. Sulfur containing amino acid are cysteine. Let's talk about this serine and threonine. Hydroxyl group containing amino acid, serine and threonine. So if you don't understand, let me know in the beginning only. I heard somebody doing kitchen work also. I heard that. So that also make me feel bad. Now NH2 and CO. This is acid, amino acid. And with amino acid, which side chain is attached? When you attach this, what does it become? What is this amino acid?
Alanine.
Yes, alanine. And to this alanine, if you add OH group, this becomes serine. Got this? To this alanine, if you add OH, this becomes serine. Now, Threonine is also a hydroxyl group containing amino acid. Now let's draw the structure of serine also. So this is amino, this is acid. Now this is what? Alanine. To this I have added OH. So this is serine. Serine. If you add at the end of this serine CH3 group, this becomes threonine. In between serine and threonine, which seems complicated little bit, a branch chain and type of a complicated type structure.
Threonine is more complicated.
Yeah, and that is why this is essential amino acid. And you can compare this amino acid with this is with alanine. So if you understand the structure of alanine, you will understand the structure of serine and threonine also. And you can write the serine structure like this also, as I've told you. This is alanine. Okay, if you put amino group here and this COOH group here, and then what else? And then OH group at the last. This becomes serine. And for threonine, just draw this. You will have to put one more CH3 and then OH here, and then NH2 here, and then COOH3. Little bit different. So I will correlate this with, because see, if you see this serine, the middle codon for serine will also be C. Middle codon for this alanine is also C, and you see this is very similar to C. So I will make you correlate with that so that you will remember the codon also. From if you understand the structure of amino acid, I will correlate that structure with the codon also, so that you will remember codon also. I'll give you a trick to understand codon also. So when I talk about I'm talking about this detail about amino acid, I am preparing you also for translation process so that you will understand the thing really deeply. That is why I am going this through this structure. Now, did you understand this too? Hydroxyl group containing amino acid.
Yeah.
Now, let's talk about this sulfur containing amino acid. The sulfur containing amino acids are two, cysteine and methionine. Now, again, it is also very simple. So let me draw the structure of this. This is also very structured. This is sulfur. You know, if you understand the simple sulfur containing amino acid, that's well enough. Now let's draw again the structure of alanine. This is acid and this is amino. And this is H, and this, when you add one carbon, this becomes alanine. To this alanine, when you add this sulfur group, just like you can see this, you can compare this with, what? You can compare this with serine. Serine, there was OH and here SH, because this amino acid is synthesized from the carbon. It gets carbon from serine only. This cysteine gets carbon from serine. So this is cysteine. So cysteine has very similar structure of serine, but it has got SH group. You add SH group to alanine. This is serine. So did you understand? This is cysteine. Sorry, this is cysteine. So did you understand the structure of cysteine?
Yes, sir.
Now, I will again draw the structure of methionine. So this is amino. This is acid. At least even if you don't focus, you will. I am confident that you will understand the structure of at least general structure of amino acid. Even the least attentive person. Even if you don't remember that general structure also, I will feel that you will just switch on that and you will go somewhere. So this is what? Alanine. You add one more carbon like this. Now with this carbon, you add sulfur. To this sulfur, you add. So you can see the structure of this methionine is a bit complicated. Can you see? This is methionine. Can you see complicated structure? Can you see this complicated structure?
Yes.
I'll make it simple.
Yeah.
No, I'll make it simple. But my job is to make everything simple. So let's see how simple I'll make it. So do you agree this is the structure of this alanine?
Yes, sir.
Now, to this alanine, add this ether group. Do you know ether? What is ether? Thioether. This is ether. When carbon is bound to two, oxygen is bound to two carbon directly like this. So this is ether bond. Okay, this is ether bond. And then when it is bound to, when sulfur is bound to two carbon, this is called thioether bond. Now just add this thioether to this, to alanine. This is methionine. Now do you remember the structure of methionine? Can you draw the structure of methionine easily?
Yeah.
This, if you remember the structure of alanine, then you can draw it easily. If you don't remember the structure of alanine also, this alanine also, then it will be difficult. So remember the structure of alanine. This is amino acid with one methyl. This is alanine. Just add this thioether group, CH2, sulfur, CH3 group. That's it. Carbon, sulfur, carbon group. Add to this. So this is methionine. So which among this, which is complicated? Just tell me.
Methionine.
So this is, that is why this is essential amino acid. Now carbon, this cysteine is synthesized from carbon. Cysteine gets carbon from this part from which amino acid? Serine, during synthesis. So I can't go into detail of synthesis, but gist of synthesis I am telling you, because you can see the structure are very similar. Now this structure, this, it will get this structure from here. This sulfur go there. So sulfur, this cysteine gets sulfur from methionine and this carbon from serine. So carbon plus serine plus methionine will make cysteine. Okay. You understand this all structure? If you understand the alanine structure, you will understand this. So did you understand all this? Now we will go to acidic amino acids. So these two are acidic amino acids. These two are acidic. These two are acidic amino acids. And from glutamate, glutamine is synthesized from aspartate, asparaginase. Now let's talk about these two. Now do you know the structure of oxaloacetate?
Sir.
Yes, I have actually spent time on drawing the oxaloacetate in my class. So this is, you can say this is oxalic acid, a bit of oxalic acid. So if you add OH group here, it becomes oxalase. And this is a part of acetate. This becomes oxaloacetate. And this oxaloacetate is synthesized from which molecule? Anyone?
Aspartate.
Aspartate is amino acid. Okay, it will be synthesized, but oxalo, it will be synthesized by transamination reaction. Okay, from this is a actually reversible transamination reaction. Transamination reaction. From this, amine will be, if amine is added, it becomes aspartate like this. So in place of this, it becomes aspartate. Now this molecule is synthesized from which molecule in our body? By carboxylation reaction. Actually, I don't feel you go through my lectures when I teach. Nobody bothers to go around the lecture. Nobody actually revise.
Pyruvate.
Yes, pyruvate. Good, thank you. So it is synthesized from pyruvate. So biochemistry, if you don't revise, it will not work. So CO2 will be added. The enzyme here is pyruvate carboxylase. This is a ligase, that's why it will require ATP. And also biotin. Pyruvate PC is biotin containing enzyme. I have repeated this reaction many times. If you don't revise, this is the problem you will have. You don't remember because you don't bother to revise this. This is very important reaction. So this carboxylation at this position, if you can see, I have explained it very nicely. At this position, if you can see here, so addition of this carboxyl group. So this is aspartate. Aspartate is synthesized from pyruvate. Now this from this aspartic acid, this oxaloacetate. So if you remember the structure of oxaloacetate, you will remember the structure of this aspartate also. Now let me draw the structure of aspartate also. So this is amino, this is acid. Now this is H group. So what is the structure you will find here is this structure. So you will draw alanine here. On this alanine you add acid. So this becomes aspartate. So that way you can remember this way also. To this alanine add one acid. So this is a 4-carbon compound. Aspartate is a 4-carbon compound. Oxaloacetate is also a 4-carbon compound. Now, so we have talked about this aspartate. So what is glutamate? So glutamate is made from
alpha ketose.
Alpha ketoglutarate. Alpha ketoglutarate is an intermediate. Both oxaloacetate and alpha ketoglutarate both are intermediate of Krebs cycle. Okay, and this alpha ketoglutarate is an intermediate of Krebs cycle. Now this alpha ketoglutarate, this was aspartate is 4-carbon. This is a 5-carbon. So again, you will draw like this. So this is keto alpha position, alpha keto, and glutarate means 5-carbon dicarboxylic acid is glutarate. Whenever you see glutarate, it is a 5-carbon. This is 5-carbon dicarboxylic acid is called glutaric acid. This is called glutaric acid. Now this glutaric acid, you can see this glutaric acid. This is alpha ketoglutarate. This alpha ketoglutarate through transamination reaction. So transamination reaction. What will form? It will form glutamate. This is glutamate. Did you understand this glutamate? This is amino and this is acid. H group is there. Now this is CH2. To this CH2, this is a bit structure similar to alanine. So if you write the CH2 and one more COOH, this becomes glutamate. So this is the side chain here. This is the side chain. This is glutamate. Now, so you have already understood glutamate and aspartate. So this is, let me draw the structure again of aspartate. This is amino and acid. What is this side chain in aspartate? Is CH2 and then COOH. Now let me draw the structure of like CO and at the OH. This is the structure of what? Aspartate. Now what will happen when you add amino group here? When you replace OH with the NH2 group, what does this become? This become asparagine. Now let me draw the structure of glutamate. This is acid, this is amino. Now, so one more carbon than aspartate or asparagine, you can see. So you draw one carbon like this, and then here OH, and then on this. So this is the structure of what? Aspartate. If you add one OH group here, but if you add NH2, this become, so this is the structure of glutamate. When you add this NH2, this become glutamine. So the structure of this is 5 carbon. You can see 1, 2, 3, 4, 5. There is one H. Now if you see, so this 4 structure are very similar. This 4 structure are very similar. So glutamate from alpha ketoglutarate, a 5 carbon compound, and then from glutamate, glutamine can be synthesized by addition of NH3 group here. Now from oxaloacetate, both are intermediate of Krebs cycle. Aspartate is synthesized from aspartate, asparagine is synthesized. So these 4 compounds are very similar in structure. These are acidic and these are amide. You can see these are amide, these are acidic. So these are all non-essential, because I have shown you alpha ketoglutarate is part of Krebs cycle. Oxaloacetate is also part of Krebs cycle. Both are synthesized in our body. So that is why these are non-essential. If you understand detail, you don't have to memorize that mnemonics. You will easily understand which is essential, which is non-essential. Now, these 3 are basic amino acids. All 3 basic amino acids are essential amino acids. So I will talk about this a bit at last. First, let me talk first about this proline. So this is, what is proline? As you see the name pro, so it is pro. So this is, from this pro I will draw the structure of proline. This is acid and this is amino group, and to this here is side chain. What is the side chain? What side chain should be here? Pro means how many carbons should be here? Side chain. Pro means 3. So 3 carbon. 1 carbon, but 3 carbon is in chain. Second carbon, and then this is 3rd carbon. So this is 3 carbon. This 3 carbon is in chain, and this is bond with this. So you can see a pentane type of thing. So there will be only NH. So do you see this structure? So you can find this structure very similar to P. So you can remember that way, P for proline. And for codon, if you see codon pro, you will see here 3C will represent proline. Pro means 3, and here you will see 3C, 3 carbon. Here 3 carbon, and this 3C, you can repeat like this. And this become the codon for proline, a very funny correlation. Codon for proline. Now, did you get all this? Let me talk about this aromatic. So you can see this aromatic amino acid, phenyl and alanine. Phenyl and alanine. So did you see this phenylalanine? So this is aromatic, 3 aromatic amino acid, you can see. Let me first talk about phenylalanine, then with phenylalanine I'll talk about tyrosine and then tryptophan also. So see, you already know alanine. What is alanine? This is amino, and this is amino, this is acid, and this is alanine. Now add a phenyl group to this benzene ring. This is nothing but phenyl alanine. The name suggests this structure. This is phenyl and this is alanine. This whole structure is alanine, phenylalanine. Now, when you convert this, when you put a hydroxyl group here, NH2, go through this video very carefully, once or twice. Even then, if you have problems, just let me know. This is phenyl. Can you see? Now hydroxyl group you add here. This becomes phenylalanine. This becomes tyrosine, sorry. Tyrosine. Did you get this?
Yes, sir.
Okay. So again, let me draw the structure of alanine. So see, alanine, how helpful this structure of alanine is, you will find here. So let me draw the structure of this alanine. Now this is the structure of alanine. Now, so let me draw the structure of a very important type, a very different type of compound. This is pentane ring. Can you see this is this type of ring? Pentane ring with one nitrogen. Now with this pentane ring, I'll draw this. Okay, like this. Okay, this becomes, this whole group is called indole. Indole group. This whole group is called indole group. Indole. So this amino acid is which amino acid? Tryptophan. And tryptophan has which group?
Indole.
Indole group. Remember this. So very simple, draw a very simple structure, sketch like this. So one pentane like this. This is called pyrrole ring, is attached to this. And this whole alanine is attached to this ring with this pyrrole ring. Okay. So this is indole. Now from this name you will get, you will hear name later indolamine. And that is why indole, remember this indole group. This is very important. This group is present, indole group is present in tryptophan, and phenyl group is present in phenylalanine, and this hydroxyphenyl group is present in tyrosine. Did you all understand very simple, in a simple way, the structure of this all this aromatic amino acid? These are aromatic amino acids. Did you all understand? The structure of aromatic amino acid.
Yes.
Yeah.
Okay, so you'll have to repeat also. See, you'll have to repeat also. So I understand that in this single class it will be difficult to memorize you all. Just understand this, and I'll upload this video and revise this video 1-2 times. If you revise, if you have a command over this amino acid structure, you will do a bang. I guarantee that. Now, so there are 3 this basic amino acid. So here see, this is proline is amino acid, and this is there are 3 basic amino acids. One is called lysine, arginine, and histidine. So we will talk about these 3: lysine, arginine, and histidine. They have complicated because all are essential amino acids. We will talk about lysine, and then we'll talk about arginine and histidine. So if you understand the structure of this amino acid, I will correlate that structure with a little bit structure with that codon also. If you want, I will make you memorize all the codon. Not in one. You have to work. I cannot put into brain. You have to work hard to memorize those. If you memorize those all, it will be very easy. So now see, lysine. What is lysine? Let me draw. This is amino, and then this is acid. Now this is H. So you will put here. This become alanine. Now to this alanine you put. This is alpha carbon. Do you know naming? This is beta carbon. This is gamma. This is delta, and this is epsilon. Why I'm writing like this, you will understand. Now to this alanine add 3 carbon, and L for a long chain. Remember L for just like that only, just for convenient. It is a long chain. Now this epsilon, there is 1 amino group. So this is lysine. This is lysine. Don't you feel like L, big L? Don't you feel like L? Lysine is like L.
Yes, sir.
Yeah, on the top of this L, there is NH2 group. This L is made up of this 4 carbon. If you consider this as alpha carbon, this is made of 4 carbon. This is carboxy group. So remember this 4. Lysine has got this epsilon amino group because this is very long. That is why, and this is 6 carbon compound. You can see at epsilon group, and this is called epsilon amino carrying group. So lysine is important for reaction. Many reaction will be catalyzed because it is a long chain. So this amino group can bind with some other compound, and then it will help in reaction. So this is called lysine. So this is the structure of lysine. Now let me draw again the structure of arginine. This is acid, and this is amine. Structure of arginine, if you draw this, three carbon, okay, alpha, beta, gamma, delta. You put delta. Okay, to this delta position, so you do like this: NH2 group, N group, carbon group. So let me draw a bit fancy way so that you'll. I'll make it simple. Don't worry about it, though it seems very complicated. So draw a carbon here. Again, one nitrogen here, and then again one nitrogen here. So put a double bond anywhere on this nitrogen. To this double bond, only one H will be there. This is NH2. Did you get this structure? Did you get this structure? And draw this. See, this is, isn't it a very similar to triangle? Isn't it very similar to triangle?
It is.
Yes.
A triangle where nitrogen is placed at the apex and carbon is at the center. With this carbon, draw a bond. So this group is called. So is it time? We have time for a minute. So we will finish at least side chain. So this is called, this very important group is called which group? Guanidino group. So guanidino group, if you remember the structure of guanine, I told you, if you remember the structure of guanine also. Sorry. So if you remember the structure of isn't it the structure of guanine? Here one NH2, here CO. Isn't it the structure of guanine? Tell me. So this terminology, guanidino, this guanidino came from this guanine. When you actually oxidize this guanine, burn this guanine, this group will be released in a very high quantity. And when you burn this amino acid also, arginine, this group will be released. So this guanidino group comes from this. This is called guanidino group. With 1 carbon, 3 nitrogen, guanidino group. Now you can see, so to this 3 carbon, here this guanidino group is bound. This is arginine. Remember the name of guanidino and name of this epsilon amino group. This is called arginine. Now if you understand the structure of this guanine, you will also understand the structure of this histidine very easily. This is acid. This is amino. Draw side chain. This is alanine. To this alanine, draw this structure. Full structure. Draw this structure. So draw this structure. Little. I will bend little bit so that it will be demarcated. And group here. Don't really focus on this double bond right now. So this whole is, this is which group? What is the name of this group? Anyone tell me? Actually, I have, this is a revision. I had already told you. What is
Indo group?
Yeah, diazo. This is diazo. 2 nitrogen is there. And pentane with 2 nitrogen. This is called diazo. Imidazole. Imidazole ring is present in histidine. This is histidine. So did you all understand this structure? These are the complex, most complex structure you can see, but you can remember easily what is guanidino. I have tried my best to make it very simple. So I have connected this 2 structure of basic from guanine, so that you will remember the structure of this purine also, and then you will remember the structure of amino acid also. So can you, did you understand this?
Yes, sir.
So remember the structure of all this amino acid. So these are the classification based on side chain. So you can see. So which of the following is an essential, which is of the following is not an essential amino acid? Just answer this question.
A.
A. Which type of?
Yes.
Which amino acid do you place into group? Which group do you place this amino acid into? Valine.
Not
Based on site.
essential.
It is which type of?
Branch.
So valine is a branch chain. So branch chain is always a complicated and essential. Not an essential. Lysine is a branch chain. It is also essential. And then tell me which is the answer.
It's tyrosine.
Yes, tyrosine, because tyrosine is a hydroxyphenyl group that is synthesized from phenylalanine. When I write phenylalanine, this type of structure should come. This phenyl group should strike into your mind. Then alanine. This is phenylalanine. Now, this is the answer. Now, amino acid residue of albumin, which has a role as buffer to balance acid base in blood. So this is histidine. Histidine has a role in as buffer. It has role as buffer. Buffer means it balances pH. It all the H plus ion. So histidine is a very important amino acid. This imidazole ring of the histidine plays very important role in buffering action. Remember this. This is a theory. So you can see easily on this PowerPoint. So H group here, CH3, you can see this easily. You can find all the side chain. Now you can understand the side chain. So this is mentioned. This is alanine. Here you have put this. This you can easily understand now. This is alanine, OH group, aspartate, and from aspartate asparagine. This is glutamate. You put one more carbon in comparison to aspartate. This is 5 carbon. This becomes glutamate and glutamine. These are acidic amino acid. You can see. Now you can easily understand N to this carbon 3 and is attached. This is guanidino group. So this 3 carbon guanidino group is attached. This is alanine to this is 4 carbon with 4 carbon amino group is epsilon amino. You can easily see this. Now here also you can see with histidine. Histidine you can see. You can easily understand proline. So this is pro 3 carbon with this attach this proline. Now you can understand this phenylalanine easily. This phenyl tyrosine you can hydroxyphenyl group. Can you see indole group here? So did you see? So now you understand everything. You have a grip over this structure. So it is not a joke if you have a grip over this structure. It is not a joke. Remember this. It will become very strong. Your biochemistry will become very strong. Okay. So this is all for today. We will talk about this pKa in next class.